I'm going to introduce a function called the cross function. So this cross function is used to indicate to us when two lines cross each other. So these two lines could be two MAs or could be two prices. Before I do that, we first talk about why do we need a cross function. What is wrong with our old method? I'm looking at Belinda sizing here. So this is our old method to do a cross. But there is a problem with our old method. Let's look at the chart on the left. The blue line represents MA20. The red line represents MA40. So I'm going to run through what Belinda does as time goes from t equals to 1 all the way to t equals to 3. Okay, let's assume that we are at t equals to 1. There's no cross, so no trades happen. And then we move on to t equals to 2. And I look at my rule here for signal cell. If SMA 10 shift 2 is greater than SMA 40 shift 2, which is true, and SMA 40 shift 1 is greater than SMA 10 shift 1, this is not true, as now both points are equal. Shift 1 is time 2 right now. So we move on to time equals to 3. So now we are at this point. SMA 40 shift 2 is equal to SMA 10 shift 2. That is correct. This is shift 2 here. They are equal. And we move on to this part where SMA 10 shift 1 is greater than SMA 40 shift 1. And that is correct as well. Shift 1 is represented by these 2 points here at time 3. So what Belinda will do is it will fire a buy trade. And looking at this chart, we know that there isn't a buy trade. SMA 20 did not cross SMA 40. So hence we need to find another method to identify crosses for us. And that will bring us to our cross function. So this is our cross function. I know that this piece of code is a bit daunting, and honestly, it is probably the most complicated code we have done so far. So let me explain how does this cross function work. So here is the main idea. It does three things. First, it finds out which line is on top of the other one, whether SMA 20 is on top of SMA 40 or SMA 40 is on top of SMA 20. Second, it will find out if there's a switch in this order. So if a switch occurred, that means that there was a cross. And the third and last thing that it does is that it will output the values of either 1 or 2, and this will represent which direction did the cross happen. Okay, so here we go. The cross function takes in two inputs, line 1 and line 2. In our example, line 1 will be MA20 shift 1, and line 2 will be MA40 shift 1. Okay, I'm going to skip this part first. It will check if current direction is the same as the last direction. They are not the same, that means a switch has happened. So what does current direction and last direction mean? Current direction equals to 1 if line 1 is on top of line 2, and current direction equals to 2 if line 1 is below line 2. So let's say in our example at t equals to 1, current direction will be 1. So current direction is 1 because line 1 is above line 2. Ignore this part first. Okay, so in this if function, this current direction is the same as the last direction because before this, line 1 is above line 2 as well. We now move to time equals to 2. Current direction remains at 1 because the two values are equal. Line 1 is neither greater than line 2 or less than line 2. So current direction stays at 1 and last direction is still 1, so no change, nothing happens, and move on to time equals to 3. Now we are at time equals to 3. Current direction is 1 because line 1 is above line 2. Therefore, current direction is equals to last direction, so nothing happens again. And this is the correct result. The cross function did not signal across because a cross did not happen. So let us look at what happens if a cross did happen. So in this example, line 1 is MA20 again, and line 2 is MA40. At t equals to 1, current direction is 1. Alright, so current direction is the same as last direction. Last direction is 1 as well, so nothing happens. At t equals to 2, the current direction does not change, and therefore current direction is equal to last direction as well, so nothing happens. But at t equals to 3, line 1 is now less than line 2, so current direction changes to 2. Right now, last direction is 1, so current direction is not equal to last direction. Therefore, we first assign our last direction as 2, which is the value of current direction. This is for the next tick. And then we return last direction. And last direction is 2. I have put some notes here about the function. If output is 1, it means that line 1 cross line 2 from the bottom. If output is 2, it means that line 1 cross line 2 from the top. In our case, the output of this function is 2. That means that line 1 cross line 2 from the top. Looking at the chart, we know that this is true. So the function worked correctly. There are 2 more things I want to talk about for this function. The first thing is this part. What does it mean? When we first run this function, it has no way of knowing what the last direction is. Let's say that we are at time 1 and then we run the function. How would the EA know what the direction was before this? So therefore, every time we run it for the first time, we have to first set our last direction as our current direction. That is what this part is for. And then of course we set first time equals to false, because now when we run it again, it's not the first time anymore. Second thing I want to talk about is this line here. Setting a new direction for the next tick. So what this does is that, because in the next tick, the current direction for today will be the last direction for the next tick. Therefore we set up last direction equals to current direction. Since we did that, we output last direction, or in fact we can actually output current direction as well, because they are the same. Okay, there's also one more thing I want to bring across. When coding this function, we need to declare these 3 variables. 2 integers, which is current direction and last direction, and the variable first time, which is the boolean. These are declared at the start, before the init part. I know that this may all seem a bit daunting to you, and honestly it probably is. It's quite difficult to understand on the first try. So when you look at it on your own, and when you're trying to understand how does it work, visualize the chart in your head and run the data through this function and imagine what will happen when the cross occurs. Alright, I have included 2 scripts. One is called bundle-sizing cross function incomplete, and the other one is complete version. In the incomplete version, there are 2 TDLs. And this first one is to declare the variables needed for the cross function, and second and third TDL are to replace the entry rules and the exit rules with the cross function. The answers are in the complete version.